Welcome to Geometry. This is Unit 3 Congruence, Section 2, which talks about angles of triangles. We're going to start off with the angle sum theorem for triangles. Most of you actually already know this, but the triangle angle sum theorem just tells us that the sum of the angles of a triangle equal 180. So if you have a triangle, the three angles, so if this is angle 1, 2, and angle 3, angle 1, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 should equal 180 degrees. And that is for any triangle. Exterior angle. An exterior angle is also referring to a triangle, and it is formed by one side and the extension of the adjacent side. So for example, here on this diagram of a triangle, if I use this one side, and then I extend an adjacent side to the side right next to it, this would be an exterior angle. Okay. We also could extend, using the same side, extend our other side right up here, label that angle 5, that would also be an exterior angle. So those are both examples of exterior angles. It just has to have one of the sides and then the extension of the adjacent side. All right, remote interior angles. Remote interior angles are the two angles not adjacent to the exterior angle. So in order to find the remote interior angles, you need to know the exterior. So for example, on this diagram here, we currently have that angle 4 is the exterior angle. So now we want to determine which two angles are not adjacent to, so are not next to. 3 and 4, they're right next to each other. So 3 is adjacent, so that means 3 is not remote interior. Instead here, the remote interior angles would be angle 1 and angle 2. Because angle 1 and angle 2 are not next to angle 4. And then we have something called a corollary. Corollaries are, it's just a direct result from a theorem. A direct result from a theorem. And these theorems, recall, are something that had to be proved, but once when they're proved, they're accepted as fact. So corollary, it's a result because of our theorem. Our theorem here is the angle sum theorem that says three angles of a triangle have to equal 180. So our two corollaries is, the first one is the acute angles of a right triangle are complementary. Well, let's think about that one for just a second here. So if we have a right triangle, that means one of our angles is 90 degrees. If all three angles have to add up to 180, so here we have two angles left. Angle 1 plus angle 2 plus our 90 degrees should equal 180. Well, if I just want to get my other two angles alone, I would subtract the 90 from both sides. So that means angle 1 plus measure of angle 2 should equal 90 degrees, which is the definition of complementary. So that is just a corollary of our angle sum theorem. So if we have one 90-degree angle or a right triangle, we know the remaining two angles must add to equal 90. The second corollary that we have is that there can be at most one right or obtuse angle in a triangle. And this is actually, we can use this example over here that we just drew to help illustrate that. So if we have one right angle of 90 degrees, the resulting sum of the other two angles has to be 90. So that automatically tells us that those two angles both have to be acute. So when we have a triangle, we can only have one right angle or one obtuse angle. So now we're going to do some examples. So what we're going to do first is we want to find the missing measures. Okay? So up here we need to take a look and see, based off of our diagram, we want to see if any angles are equal to each other, and we also want to keep in mind that the sum of the three angles has to equal 180. So right here, I see a triangle where I know two angles, and I want to find the third. Well, the three angles have to add to be 180. So if I add 43 and 74 up, we get 117 degrees. That means 117 degrees plus whatever our missing angle is should be 180. So we can just take 180 and subtract 117 from it. And that gives us our angle 1. So when we do that, we get 63 degrees. So the measure of angle 1 is equal to 63 degrees. Justify why. Here is our reasoning why. It is the triangle sum theorem. There's an abbreviation for it, triangle sum theorem. Next, let's find the measure of angle 2. Notice angle 1 and angle 2 are directly across from each other. They're vertical, so that must mean that they should be equal. So angle 2 is also 63 degrees. Justify why. Vertical angles are congruent. And that's something we learned in the couple units ago. And so now we have angle 1 is 63 degrees, angle 2 is 63 degrees, and we just need to find angle 3. Well, once again, if we take a look at angle 3, we know two of the angles. We just have to find the third. So that means that we need to add our two angles up together that we know. So we would take 63 plus 79 and get 142. And then we would have to subtract that from 180. 180 minus 142 is 38 degrees. So the measure of angle 3 is 38 degrees. And the justify why is the triangle sum theorem. So this is your final answer, and yes, you do need to make sure that you are justifying why on every single step. Next diagram looks slightly more intimidating, but we just need to work our way around it. Typically when we have these, we should usually be able to start by finding angle 1 and then work our way through. So that's what we are going to try to do here. So we're going to start with angle 1. Here's angle 1. Notice that angle 1 is exterior to this triangle right here. Since angle 1 is an exterior angle, we can just add the two exterior angles up, and that should give us our exterior angle. So that means angle 1 is 63 degrees. Now let's delve into that a little bit further as to why that works. Well, we know if we add these two angles up and then subtract from 180, we're going to get the third angle of the triangle, so we'd get this to be 117. But then to get angle 1 again, we would just have to take 180 minus 117, and we'd get back to our 63. So whenever we have an exterior angle, exterior angle is equal to the sum of the two remote interior. So that's a kind of a quicker way to find the exterior angles. And so 63 degrees, and there's our justification why. Okay, So angle 1 is 63 degrees. Angle 2 now, if you look, angle 1 and angle 2 form a linear pair. So they need to add to be 180. So that means angle 2 has to be 117 degrees because 180 minus 63 is 117. And we'll say linear pair for our justification. Linear pair with angle 1. All right, measure of angle 3 now. Well, angle 3 is right up in here. We do have 117, which is an exterior angle to this triangle. Okay, since 117 is exterior, that should be equal to the sum of angle 3 and 64. So we can say 117 is equal to the measure of angle 3 plus 64 degrees. Now, to get the measure of angle 3 alone, we would have to subtract 64 from both sides. So we get 53 degrees for the measure of angle 3. Exterior angle is equal to the sum of the two interior. Okay. So now we have angle 3 is 53 degrees. So now we're going to look for angle 4. Well, take a look here at angle 4. Angle 4, angle 3, and the 31 degrees form a linear pair. So since they are a linear pair, they should all form a line. So they should all equal 180 when you add them up together. So if we take 31 degrees plus 53 degrees, we get 84. So angle 4 should be 180 minus 84 degrees. So when we do that, we get 96 degrees. So measure of angle 4 is 96 degrees. And we can say angle 3, 31 degrees, and angle 4 form a line. And we know that there's 180 degrees in a line. Then last but not least, we have our angle 5 over here. So here we have 3 angles of the triangle. We know 2, we want to find the third, so we can add up the 2 we know and subtract from 180 to get the third. So we can take 96 plus 41 to get 137. And then to get angle 5, we would want to take 180 minus 137, and that would give us 43. So angle 5 is 43 degrees, and our reason why is the triangle sum theorem. Okay, so that was a slightly more complicated version, but notice how we just have to go around and find each measurement individually. And sometimes you're going to have to use a few of your previous answers to get there. All right, let's do one more like that. That's a little bit more complicated. Here we go. So once again, we're going to find all angles. Typically, if you start with the first one, the one labeled as 1, you should be able to work your way around. Of course, many times you can also start at other ones, but I just like to start at 1. So here's our angle 1. Notice angle 1 is exterior to that triangle that has 45 and 85 together. So to find angle 1, we can just add 45 plus 85 to give us 130 degrees. So measure of angle 1 is 130 degrees. Justification, exterior to 45 and 85. All right, angle 2. Well, now if you look at angle 2, angle 1 and 2 form a linear pair. So since they form a linear pair, they have to add to be 180. So we would just have to take 180 minus 130 to get 50 degrees. So angle 2 is 50 degrees. Okay, moving right along to angle 3. So here's angle 3. We don't have the third angle in that triangle, so we can't add the 2 up and subtract from 180, but we do have this exterior angle here of 135. So the exterior angle is equal to the 2 remote interior. So 135 should equal 50 degrees plus the measure of angle 3. And to get our measure of angle 3 alone, we would just have to subtract 50 from both sides, which gives us 85 degrees for the measure of angle 3. And it's 85 degrees. 135 is exterior to 50 and angle 3. Okay. Next up, we want to find angle 4. So if we take a look here at angle 4, notice that angle 4 and 135 are on the same line, so they form a linear pair. So we can do 180 minus 135 to get 45 degrees for angle 4. Justification, a linear pair with 135 degrees. And last but not least, we want to find angle 5. Notice angle 5 here is exterior to this triangle. So since angle 5 is exterior, we can just take our two remote interior, which is 45 and 75, and add them together to get 120. So angle 5 should be 120 degrees. It is exterior angle, so 45 and 75 are the remote interior. Notice for each of these we have a justification as to why. Our justification as to why was always the reason why we did the math behind it. You should always include justifications.